Availability is crucial for the Internet of Vehicles. It means users can always access vehicle-related services when needed. A major threat to this is the denial of service or DOS attack. These attacks overwhelm network resources, preventing legitimate users from accessing services. Ensuring availability is essential for the smooth operation of connected vehicles. There are several common attacks targeting the availability of IoV systems. Jamming attacks disrupt communication by interfering with signals, impacting services like navigation and telematics. Flooding attacks overwhelm the network with fake messages, degrading performance and preventing legitimate traffic. Malware can infect vehicles and roadside units, disrupting operations and potentially leading to further attacks. Spamming also contributes to network congestion and degraded performance. Last, DOS attacks, including flooding and spamming, aim to prevent legitimate users from accessing services, which can be amplified through the DOS attacks using multiple compromised devices. Imagine a highway with two lanes, one for regular traffic and the other for V2X communication. Vehicles drive on the regular lane while using the V2X lane to communicate. A jamming attack involves sending a strong signal that interferes with the weaker V2X signal, corrupting data and preventing vehicles from sharing critical information like hazards or coordinating safety maneuvers. This effectively disrupts the entire communication network, compromising safety and efficiency. To counter availability attacks on IoV systems, we need a multi-layered approach. Authentication mechanisms can be used to verify device and user identities to prevent unauthorized access. Intrusion detection systems can monitor network activity for suspicious behavior. Cryptography can protect data and makes it harder for attackers to disrupt services. To combat jamming, we can use channel switching and frequency hopping, or employ multiple radio transceivers. Malware protection through antivirus software and firewalls is essential. Packet filtering helps block malicious traffic. Finally, detecting sudden spikes in network traffic can help identify potential DOS attacks. Data integrity attacks target the accuracy and reliability of information in IoV systems. Masquerading involves impersonating other entities to manipulate vehicles. Replay attacks reuse valid data to disrupt operations. Data alteration involves modifying data content to mislead systems. Tampering attacks inject false data into the network. Last but not least, map database poisoning alters navigation maps, leading to incorrect routes. One of the most dangerous types of attacks on IoV systems is false data injection. Attackers introduce false information into the network to disrupt vehicle operations. For example, they might manipulate a vehicle's location data, causing other vehicles to make incorrect decisions and potentially leading to accidents. To ensure data integrity in IoV systems, we need several countermeasures. Secure communication and encryption can be used to protect data from unauthorized access and modification. Authentication verifies the identity of communicating parties, preventing impersonation. Sequence numbers and timestamps can help detect replay attacks. Message signing ensures data authenticity and origin. Public key infrastructure manages digital certificates for secure key management. Intrusion detection systems monitor for suspicious activity, and blacklisting helps remove compromised nodes. Finally, secure map updates are essential to maintain accurate navigation information. Autonomous vehicles and intelligent transportation systems rely on a constant flow of sensitive data, including location, safety messages, and personal information. This makes them prime targets for confidentiality attacks. Adversaries can exploit vulnerabilities to steal this data, compromising privacy and potentially disrupting operations. One common attack is eavesdropping, where attackers listen in on network traffic to capture valuable information. While this doesn't directly impact network functionality, it still poses a serious threat to data confidentiality. To safeguard against confidentiality attacks, we need to implement several countermeasures. Secure communication protocols can prevent eavesdropping, while privacy-preserving methods like data anonymization can mitigate interception attacks. Establishing trust and efficient credential management systems using digital certificates is also crucial to protect against insider threats and unauthorized access.